Chapter 3, Chemical Equilibrium, School Year 2021, Class Life Science. Part 1, Study of the Esterification reaction. At the end of this session, students should be able to verify whether the esterification is a complete reaction or not. Introduction. Chemical reactions could be complete and incomplete. In case of complete reaction, at least one of the reactants, the limiting reactant, disappears completely and products do not react to form reactants. One-way direction is a complete reaction. In case of incomplete reaction, reactants do not disappear completely, even the limiting reactant, because products have the ability to react together to form the reactants again. Such reactions are called reversible reactions. In reversible reaction, the conversion of reactants into product and products into reactants occurs simultaneously at the same time. The study of chemical equilibrium is limited to incomplete or reversible reactions. 1. Study of the esterification reaction. Definition. What is meant by esterification? Esterification reaction is the reaction of synthesis of an ester starting from a carboxylic acid and an alcohol according to the general equation. Carboxylic acid plus alcohol give ester plus water. RCOOH is the general formula of carboxylic acid plus R'OH is the general formula of alcohol. Give RCOOR', the general formula of ester, plus water H2O. The equation of synthesis of an ester, that means the esterification reaction, will be studied in organic parts. 2. Procedure. Mix a volume V1 of pure ethanoic acid, CH3COOH, of density D1 equal 1.08 gram per milliliter, with a volume V2 of pure ethanol, C2H5OH, of density D2 equals 0.79 gram per milliliter, in order to obtain an equimolar mixture of reactants where the initial number of moles for each reactant is N0 equal 1 mole. When we say equimolar mixture, that means initial number of mole of acid equal to the initial number of mole of alcohol, equal to 1 mole in this case. Heat the mixture at 100 degrees, then at different intervals of time, titrate the acid left using a sodium hydroxide solution Na plus HO minus of concentration Cb equal 1 mole per liter, in order to determine the number of moles of acid left at each instant. This is the procedure. Now, interpretation. The equation of the reaction, CH3COOH plus C2H5OH gives CH3COO, C2H5 plus H2O. In this chapter, this reaction is given. When we study the organic part, you should write this equation. Now, in this chapter, it is given in the question. Now, volume of the acid and the alcohol. For the acid, we are given, for acid, we are given density 1, volume V1, molar mass 1, density equal 1.08 gram per milliliter. V1 is unknown, molar mass 1 equals 60 gram. For the acid, and N0 initial number of mole equal 1 mole. For the alcohol, also we are given the density D2 equal 0.79 gram per milliliter. We are given V2 is unknown. We should determine it now. Molar mass M2 for alcohol ethanol is 46 gram per mole, and initial number of mole equal 1 mole. Equimolar mixture in which the initial number of mole equal to 1 mole. How can we determine the volume from density and the number of mole? We have the number of mole equal mass to molar mass, and density equal mass over volume. Then the mass equal density times volume. Therefore, we replace the mass M1 by density 1 times volume 1 over molar mass 1. Therefore, the V1 equal N0 times molar mass M1 over density 1. The initial number of mole equal 1, molar mass equal 60 gram per mole, and density equal 1.08 gram per milliliter. The volume equal 55.55 milliliter. The same for the alcohol. N0 equal mass over molar mass, M2 over molar mass 2 equal density 2 times V2 over molar mass 2. Then V2 equal initial number of mole times molar mass over density. Initial number of mole 1, molar mass 46, and density 0.79. The volume equal 58.23. Sometimes it is given the volume and we need to calculate the number of moles. Same rule, number of mole equal mass over molar mass equal density times volume over molar mass. We replace the volume by its value and density by its value and molar mass by its value. We obtain the initial number of mole. Now, determination of the number of moles of acid left at each instant. We titrate the acid left at each instant using a sodium hydroxide solution of concentration Cb equal 1 mole per liter. Given the acid CH3COH, we need to determine its number of mole at each instant, and we titrate it using sodium hydroxide solution of concentration Cb equal 1 mole per liter, and the volume of base added at equivalence equal V milliliter. According to the titration, we obtain V. The net equation of the titration reaction is CH3COH, the acid reacts with the base HO minus to give CH3COO minus plus H2O. As we know, the titration reaction is complete. At equivalence, the number of mole of acid titrated equal number of mole of HO minus added according to the stoichiometry of the reaction. 1 for acid and 1 for HO minus. Then number of mole equal number of mole added. We need to calculate number of mole, but we replace number of mole of HO minus by Cb times V because we have C equal N over V. Then number of mole equal C times V. Therefore, we can replace number of mole of HO minus by Cb times VBE. Cb equal 1. VB in this case should be in liter. The volume is given in milliliter. We multiply it by 10 power minus 3 to transform it into liter. The final value equal 1 times 10 minus 3 V in mole. The unit is mole. Therefore, the number of mole of acid form left at each instant equal 1 10 minus 3 V mole. Following the number of moles of acid left with time by titration, we get the following result, which are given in the following table, and then the graph, the following graph. Time in hour and number of mole of acid in mole. At t equals 0, initial number of mole of acid equal 1 mole. After 2 hours, 0.82. After 4 hours, 0.72. The number of mole of acid decreases because it is reactant. This continues till the instant 150 hours. The number of mole of acid left equals 0.33 mole. And at t equal 200 hours, that means after 50 hours, the number of mole of acid left remains constant, equal to 0.33. That means the reaction has ended at t equal 150 hours if the reaction is complete, because number of mole of acid since this instant remains constant. Then t equal 150 hours represent the end time of the reaction if the reaction is complete. This graph shows the variation of number of mole of acid with time. It decreases from 1 to at 150 hours it becomes constant, and so on. The graph becomes, or the curve becomes straight line. That means the reaction has ended. Now, relation between number of mole of ester formed, Ne, and number of mole of acid left. According to the stoichiometry of the esterification reaction, the esterification reaction is involved acid, carboxylic acid, plus alcohol, give ester plus water. The stoichiometry of the reaction 1, 1, 1, 1. According to this stoichiometry, number of mole at each instant, number of mole of ester formed equal number of mole of acid reacted. Then number of mole of ester formed at instant t equal number of mole of acid reacted at this instant. Number of mole of acid reacted equal initial number of mole minus number of mole left. We have calculated the number of mole of acid left by titration. We subtract it from the initial number of mole. We can deduce number of mole of acid reacted. That means number of mole of ester formed at same instant t. Then initial number of mole equal 1. Therefore, number of mole of ester formed equal 1 minus number of mole of acid left at instant t. Using this relation, we can complete this table by calculating the number of mole of ester formed in mole. 1 minus 1 equals 0. At t equals 0, the product is not formed. After 2 hours, 1 minus 0.82 equals 0.18 mole. This is number of mole of ester formed. 4 hours, 1 minus 0.74 equal 0.28, 0.26, 0.38, 0.49, 0.58, 0.61, 0.62, 0.64, 0.67, and 0.67. This is the number of mole of ester formed at the end of the reaction if the reaction is complete. Experimentally, number of mole of ester obtained at the end equal to 0.67 mole. This is the maximum number of mole obtained experimentally. Now, final composition of the mixture. According to the table 1, we have number of mole of HA left at T equal 150 hour equals 0.33. HA is the acid. Number of mole of acid left at after T equal 150 hour equals 0.33 mole, and it remains constant after this instant. Then apparently the reaction ends at the instant T equal 150 hour. But experimentally, or in fact, does this time represent the end time or something other? We will see. At the end of the reaction, number of mole of acid reacted equal initial number of mole of acid minus number of mole of acid left. Then number of mole of acid reacted equals 0.67 mole. And therefore, according to stoichiometry of the reaction, number of mole of ester at infinity equal number of mole of acid reacted, as we have seen, and equal to 0.67 mole. The same for the water, equal 0.67 mole. Then the following table shows the initial state and the final state of the reaction mixture. Carboxylic acid, alcohol, ester, and water. This is the reaction mixture. Initial state, 1 mole of acid and 1 mole of alcohol, 0 for products. At the final state, the number of mole of acid left equals 0.33. Number of mole of alcohol left also 0.33. And number of mole of ester equals 0.67. Number of mole of water equals 0.67. We can calculate it using the stoichiometry of the reaction, using the reaction acid plus alcohol give ester plus water. At T equals 0, the initial state, 1 mole, 0, 0. Variation, the acid decreased by an amount of X, and the same for alcohol because same stoichiometry, 1, 1, 1, 1. Ester increases by amount X, and water increases by an amount X. At the end, if the reaction is complete, 1 minus X, number of mole of acid left, 1 minus X, number of mole of alcohol left, 0 plus X, X is the number of ester formed, the same for water X. Right. 1 minus X equal number of mole of acid left, which is 0.33 at the end of the reaction at T equal 150. That means 1 minus X equals 0.33. Also 1 minus X for alcohol, 0.33. 1 minus X equals 0.33, then X equal 1 minus 0.33 equals 0.67 mole. The same for water, 0.67 mole. This is the final composition of the mixture. Now, number of mole of ester that should be obtained at the end of the reaction, if the reaction is complete, which is called theoretical number of mole of ester. Theoretically, if the reaction is complete and according to stoichiometry of the reaction, number of mole of ester at end of the reaction at infinity equal initial number of mole of acid or alcohol, because the initial mixture is stoichiometric. Ratio of acid equal ratio of alcohol, then the initial mixture is stoichiometric and the two reactants are limiting. Then we can calculate the final number of mole of ester theoretically from any one of the two reactants, acid or alcohol, equals the same 1 mole. Then we should obtain 1 mole if the reaction is complete. But experimentally we have obtained 0.67 mole of ester. Then the yield of the reaction equal number of mole of ester experimentally over number of mole of ester theoretically. Experimentally we obtained 0.67, theoretically equal 1. Then the yield of the reaction equals 0.67. And by percentage, percent yield equals 0.67 times 100. That means 67% is the yield of the reaction. Conclusion: in this reaction, reactants did not disappear completely. The number of mole of acid and number of mole of alcohol left at the end equal to 0.33 mole, then the acid and the alcohol, which are limiting reactant, did not disappear completely. Then we can conclude that this reaction, the esterification reaction, is not complete. This is the end of part 1, esterification reaction.